triangle here. Relative to angle 35, do we want to find A or B in this problem?
We want to find angle like the total, like the final answer.
What do we want to find here? A or B, or I guess I'll even throw in C. What are we asked for in this problem?
For B.
Yes. So important that you kind of identify what is your finding. Now, relative to the 35, what is B and what is 800? Your choices are adjacent, opposite, and hypotenuse.
Hypotenuse, opposite, adjacent. This would be that is your adjacent. B is adjacent.
Okay, what about the 800?
800 is the hypotenuse. It's the opposite of the 90-degree angle.
Okay, so which of the three trig functions are we using? So, ka, toa here. Sine, cosine, or tangent?
Oh, that would have to be a hypotenuse and adjacent. So that would have to be cosine.
Cosine. All right, good. That's important. You got to be able to map, get the right sides and then map it to this. It's the cosine of 35 equals, in this case, what over what? Is it B over 800 or 800 over B?
Um, B over 800 or 800 over B. This would be. Oh, sorry. I don't know why this is like. Yeah, it would be B over 800.
Yes. Your test is still tomorrow, is that right?
Yeah, and I actually think it might get moved back to Tuesday now as
Okay.
well.
All
Yeah, so
right.
I don't know why my brain was being so for that one. Yeah. So then
That's
with
okay.
the problem with that, we put the one below the cosine 35
Okay.
and then do like cross multiplication.
That
So then that
works.
would be B equals cosine 35 times 800.
Now I'm gonna put the 800 in front just to
Uh,
avoid sort of having a weird scenario where you
mhm.
do something else you're not supposed to. Um, I want you to use that calculator and give me the answer. Make sure you're in degrees. It usually is by default. Sometimes you can't
Uh,
tell though based on the answer, like you wouldn't know whether it was reasonable or not.
Degrees is when it does not have the negative symbol with it, correct?
No, no. If you look at, let me snip it in here. It's a feature of the calculator where it tells you, see how the DEG is chosen? That's what I'm referring to, the mode.
Oh, okay, yeah.
So the calculator wants to know whether this is in what's called degrees or radians. And
Oh, and then is the radians is like the other
it's the,
measuring thing we had.
the pi over 180 stuff that you'll get back to.
Yeah.
You'll get back to at some point.
Yeah, could we actually go after do that right after this problem, I think.
Sure.
Because I think I kind of got this down. And then my answer I got was 655.32.
Yes. And then you need
And
units. So it'd be 655 meters.
then meters, yeah.
Okay.
Yeah, I forgot what so that other so there's like the unit of measurement where it's degrees and then the other one's radians, right?
Yeah.
Radian.
Yeah, radian. Radian.
So then okay, so I guess like with the radians that has okay, so degrees uses sine, tan, and cosine.
Yes.
And then radian, is that like I can't remember the formula that
Well,
you'd be using for radian.
there's a conversion formula, but your sine, cosine, your tangent will all take in either you can either give it a degree or you can give it a
Mhm.
radian.
Oh, so I can apply this into either way. Oh, wait, am I using okay, wait, is radian on the calculator as well?
It is.
Okay, so then that is so it's like the same thing except instead of using degrees, I'm just gonna
Okay.
click the radian option instead.
Yeah, yeah. It's like let's just say here, let's do an example here real quick. Let's say I asked you for the cosine of 45 degrees. Could you put that in the calculator to give me it to 3 decimal places?
Sure. Cosine in degrees or
Yeah,
in the
in degrees. The degree, whenever you see the degree symbol, the bubble there, that means degrees.
okay. All right, yeah, of course, yeah. Cosine 45. Um 0.70, and then I
Anything else?
I just leave it at that, I think, right?
3 decimal places.
Oh, 3 decimal places. 7
Very good.
again.
Okay. Why doesn't that
By
look
that,
right?
so by that you mean how many numbers after the decimal?
Yes.
Okay, so if it's like, so what term did you use? Like
Three,
three?
three out to, here's how I should say it properly. Please write the answer out to 3 decimal places, or I could say three, um, significance to 3 digits. I mean, that's
Okay.
overkill. I mean, the shorthand is just say
Yeah,
out to
yeah.
three decimal places,
All
meaning
right,
you,
so then you know the number just by you saying like 3 or 5 or 7. Like
yeah,
that's how you know,
like I know
right?
you're going to look at the fourth and say, oh, I don't need that. It's just going to be seven oh
Mhm.
seven. Okay. Now I want you to hit the degree button on your calculator there so that it switches
All right.
to radian.
And then that
And
would make it
and then do this. We'll talk about the conversion in a moment, but I want you to see that they're the same. Cosine pi over 4.
cosine pi. All right, so just delete what my current answer is.
Or hit enter and get a new line,
All right.
whatever you want.
So cosine pi divided by 4.
Okay, and give me your answer to 3 decimal places.
0.707.
Are those the same?
Exact same.
They
And
are.
then I totally forgot because they're saying the same thing. They mean the same thing, but they have different numbers. But
That's right.
they're like but they are the same. Like in a
Yes.
yes, it's like
Yes.
Fahrenheit and Kelvin. You said or Kelvin.
Yeah, Celsius, Fahrenheit, something like that. I mean, that's not maybe not the best analogy. Um,
I think it's good.
it,
I think it got me kind of fast.
okay. Okay, so let's real quick talk about how you convert, and we'll start from the standard one, degrees to radian or radians. And to do
Mhm.
this, you multiply by pi over 180.
By
Okay.
pi over 180.
So let's do an easy one here to start out. 90 degrees times pi over 180. Now, if you're going to use your calculator, and it's okay if you are,
Mhm.
you do not put the pi in your calculator. Just put in your calculator 90
3.14.
90 over 180. No, your answer will have a pi in it.
Okay. So okay, wait. So I'm looking at this as like so this is degrees to radians,
Yes.
and then I'm gonna just multiply the two numbers together times pi.
Yes.
And then
But you don't, when you go to your calculator, don't use the pi because the pi will mess up the calculation. You have to do just the nice part, the friendly part in your calculator.
okay. All right, I guess that makes more sense. So 90 divided by 180 divided by 180. And then I leave it. So obviously I'll have 0.5 as my answer for that. And then
Or 1/2 pi. Okay.
1/2 pi. And then
Okay.
that's just my
So,
answer. Like I don't have to multiply it by pi
so that's your answer in degrees with the degree symbol. That's your answer in radians.
in radians. So I can take, okay, so I'm given like the 90 degree in this triangle. I know like I want to convert it over to radians.
So
So then
yeah, you
all I
generally
have to do is
just
just
write.
insert it into the pi over 180, and then I just get my answer from it.
Yes. So we'll do a couple more here.
Okay, so it's like, okay, so it's whatever the degrees. So I'm gonna multiply like whatever that number is for the degree times, and then pi over 180 is the formula. And then I just would put the number I have, divide by 180
Yes.
pi, and then that's radian.
So I think we got to do a few more here, and then it'll really help here. Let's do 135 degrees.
135. Okay, so then I'd do 135 times pi over 180. And then what I'd want to do is have 135 divided by 180.
Yes.
And then I'll do that right now.
And you want it as a fraction, like I know you're the decimals when it pops out, but you want to give the fraction.
Mhm. And okay, so I have a question. So I'd have it in degrees mode while I do this because it's getting converted over.
So here's what I want you to do. I want you to toggle back and forth between degree and radian and see if your answer changes for the one that we're doing right now, the 135 over 180.
135 divided by 180. So then that's 0.75 in degrees.
Okay.
And 0.75 in radians. So it does not matter in that.
It does not matter.
And then yeah, so then that would be 3/4 pi, and then that's the radian instead of degree.
That's right.
Huh. All right.
Let's do one more. Do you have a question?
So when it's in the actual like shape, in a sense, why? So it's always just like it's always just gonna have pi in the answers. Like
No, not always.
not always.
Not always. Usually, but not always. That's where your test question is going to be. I'm going to give you, I think, what your test question is. But no, like here, you're not going to like this. We should do one more though. Let's do 690 degrees.
690 degrees. So then, all right, so that's 690 divided by 180 pi. So then 690 divided by 180 is 3.83.
It's got to be a fraction. It's going to have to be a fraction in your exam.
But it has to be a fraction. So then, so should I reduce the numbers given?
I would you can convert that. There's that fraction, convert to on the right hand side, on the calculator there. Your calculator at school will also have one of these. That's one of the reasons why it'd be good for us to look at it every once in a while. But this button converts to a fraction.
That button converts to a fraction. So then convert to, so that would be 23/6.
Yes.
And then, oh yeah, that actually, and then that would be 3 and like 1/3.
But this is what your teacher wants. Probably wants this.
And so it's fine if like there's a bigger nut, like if it's a bigger number on the top.
Yes.
Okay.
Why do you not like that? What is it about that that's still bothersome to you?
I don't know. I just feel like it's just like not like I know like that's the end of it, but I just still feel like it's not like complete. Like I'm just used to like, oh, the pi is there, multiplied by 3.14 or like.
Okay, so yeah, I get it. It's kind of like the square root of 5. It's just that is the final answer. There's no more to do.
Yeah, like that's just the way it goes. All right.
Like you called this well, we said the square root of 4, which is 2. You've coined a phrase that I've used quite often. I call this friendly now, and this is unfriendly, and that's where you're at again. You're like pi over 2. It's unfriendly, but it's correct. These are both unfriendly.
Yeah.
Okay.
Yeah, I guess I'm just not used to the unfriendly numbers. So like I just feel like I need to finish it up, but.
All right, so last one for you to try before we go the other direction. What is 62.5? degrees converted to radians.
So then that'd be 62.5 divided by 180 pi. So then I will do that right now. 62.5. 62.5 divided. That would be 25 over 72 pi. And that is
Yes, it becomes 25 over 72 pi. Very good. Okay. All right, now we're going to go the other direction. So to convert from radian to degree, let me give it a little more room here. You multiply by 180 divided by pi.
Mm-hmm. So then,
So just take a look at what you wrote before,
mhm.
and compare the two. How did you go from degree to radian? What did we go to go from degree to radian?
Degree to radian, it's pi over 180.
And to go backwards, it's 180 over pi.
So then would I be dividing the number by pi and then
So I'll give you an example
multiplying?
here. 5 pi over 6. Okay. You're going to multiply by 180 over pi. Okay. Now, this is important. The pi's cancel. You generally don't put pi in your calculator, generally. Okay. The rest of it you do put in your calculator. 5 over 6 times 180.
So then that would be like 150.
Yes.
And then,
With the degree symbol.
right, because it's going to be like a whole number, like it's going to be a specific number because now it's back to degrees.
Maybe, but yes.
Or
First,
it could be like, it won't be a fraction.
we'll see. You jump to conclusions on that.
Got too excited there.
Yeah, let's try
Like
that one here.
it's gonna be like it's gonna be more like friendly in a sense because like it
Yes,
has to be like a
yes.
okay. All right, that makes like a lot more sense now with the other one. Why it's not like so friendly as well. All right, yeah. So then
10 pi over 3. 10 pi over 3.
then am I gonna write 1 times 180 over pi?
Yes,
And then the pi's cancel each other.
that's right.
And then is the answer 600?
It is 600, yeah. Okay, so
Okay.
it's not bad when it works, right?
Yeah.
Okay, but it doesn't always work. Like if I give you oh, I don't know, let's go 11 pi over 56.
11 pi over 56. And then you'd write 180 over pi. And then yeah, okay, now I can see why now it's not so easy. I can't just do it mentally. Yeah, so then so the pi's would cancel out, so then it's 11 times 180 over 56.
Okay, so this one, go ahead and round it to like 1 decimal place.
All right, I'm just gonna write this down. 11 times 180 divided by 56. 11 times 180 divided by 56. And then how many decimal points places do you want?
Just one decimal place.
35.3.
Okay. Very good. All right. Now, so here's your test question. I mean, this is what I remember just from years past, is it will say convert 2 radians to degrees. Okay. 2 radians to degrees. All right. Now notice there's no pi.
Mm-hmm.
You still take that number and you multiply by 180
Over pi.
Yes.
And then okay, wait a second. So then it's just wait, why am I not? Okay, wait. So this is the same. So this is what I was literally just doing.
It is.
Correct.
So let me change the problem here. 2 pi radians to degrees. Now it's something you like because you're like, oh, the pi's cancel,
Yeah,
right?
they cancel, then it's just 360.
It is
So then,
360. But now let's actually do the question that I really want you to do, because this is what, I remember that being on your test, something like this where it doesn't look right.
uh,
Okay.
so count 2
2
radian.
radians. So it's 2 times.
So what I write, it's like I don't write 360 over pi, correct?
You can, but then you should go to your calculator because it'll say something around a 1 decimal place.
All right, so then 360 divided by 360 divided 114.6.
Okay, very good. Now, have you guys talked at all about the unit circle?
I do not believe so.
Okay, so let's try another one. Convert 1.2 radians to degrees.
1.2 radians, 2 degrees. Okay, then that formula is 1.2 radians to degrees. So I know it's 1.2 times 180 over pi.
Very good.
And then I'll just, type that into the calculator, of course. 1.2 times 180 over pi. So then 1.2 times 180. Shoot, I don't know. I messed up one part on this 1 second.
So none of these are going to work out nicely. I mean, they're just, that's the whole point. It's to gauge your comfort level with like things that don't look right.
Yeah. I got 68.7.
That is, well, 68.8, but yeah, I'd take it.
Oh yeah, actually now that I look at that, that's correct. 67.8.
Okay,
So
so
then,
any other questions on this? I mean, we've gone both directions. I've given you sort of what I remember to be that test question.
mhm.
Um,
I think I'm good with it. Thank you,
okay.
because I kind of forgot about that actually until you mentioned it. Um, yeah, I guess that's not really too tricky. It's just kind of just knowing the formula.
That's right.
I guess there's not really like any tricks to it or anything in a sense. It's just like a matter of, just doing it right.
That's right.
Okay. All right. Yeah. Thank you. I got that now.
All right, so we should go back and do a couple more word problems here. Those are generally the most difficult problems here. Let's go to number 12. If that's okay.
Sounds good to me.
Okay, the angle of elevation from a ship to the top of a 42-meter lighthouse on the shore measures 33 degrees. How far is the ship from the lighthouse? Assume the horizontal line of sight meets the bottom of the lighthouse. Again, like I'd like you to try drawing the picture, um,
Uh-huh.
just to see where that is on your end. Just so go ahead and make a drawing. Even if you redraw what's already on your page, that's fine. But give me, just take another look at it, see if you think that's right. I'm not saying it's right or wrong.
Mhm.
I'm just asking you to confirm that.
Um, okay, so I do believe I have it.
Okay. Did you draw a triangle like this?
I did draw one like that.
Okay, so this is 33 degrees.
Uh-huh.
Is A, B, or C 42?
B.
B. Okay, so 42 there. And what are we trying to find? A, C, or I guess I'll even call this D.
Um, we'd say A.
We were trying to find A. So it's sometimes good to just, if you've drawn extra letters to get rid of them real quick. Okay,
Uh-huh.
relative to the 33 degrees, what is A and what is 49? And your answers are adjacent, opposite, or hypotenuse.
A is the adjacent, and then that's adjacent and opposite,
Okay.
which would make it Uh, sine.
So you've got to get this down. So ka toa, you got to know that. Like when you roll out of
Mhm.
bed, you got to know that.
So all right, yeah, that would be tan.
Okay, so it's
Opposite.
tangent of 33, and then what goes in the numerator, what goes in the denominator.
42 over a.
Okay,
And
so
then,
I'd like you to try solving this from here.
all right, we'll do it. And
And,
count like all the way to the end, correct?
yeah, and now your calculator, make sure your mode is in degrees.
All right.
Now it
Yep.
actually matters.
42 a equals. And then 64.7.
Pumpkins, elephants, what do we got over here?
We have meters.
Meters. No, it's not pumpkins, not elephants. Okay. Yeah, I would say you have that down pretty well. Where else on this page should we go? There is a problem that I don't think is on your test, but I don't remember these things like this. This is I don't know how comfortable this is. This is usually an honors type question.
Um, I would like to go over that because I feel like, yeah, I would like to go over that.
Okay. Any idea how you might start this?
Um, I guess I can look at it as like a squared plus b squared equals c squared.
That's right.
And
A,
then,
B, and C. So you literally write just what you said. X squared plus 10 squared equals 20 minus X squared. Now, the only way you can go wrong is if you forget how to deal with what's on the right here. And to avoid doing that, you want to write it out as two separate binomials. And
and then am I gonna make it
you're gonna
do
foil.
the foil? Yeah, foil. So it's like 20 times 20,
Yeah, so
20 times.
I'd like you to foil that.
Okay, and when I foil, I'm gonna put into account that there's negative signs, correct?
Yes. Yes.
All right. 20. Oops, I already redo. All right, there we go. 400 minus 20x. And then 400 minus 40x plus. Okay, so now I have 400 minus 40x plus x squared.
Okay, so you want to get everything on one side of the equation.
Oh,
Maybe,
right, and then there's the x.
maybe, but like, and the reason I say maybe is because there's variations of this problem. But do you see how the x squareds cancel?
Yeah.
So that means you actually don't have to. You have your choice now. You can solve however you're comfortable, but the x squareds go away.
All right, I'll be. Or I could easy for myself. I'll just say 40x equals 300, and just
Yeah.
like
Well,
add,
yes. 40x equals 300.
and then I would have x equals 300 divided by 40.
Okay. So if you left it like that, I'd probably deduct at least maybe a point, maybe 2 out of 10, something like that.
Mhm.
So can you do anything more from here?
I mean, I guess you can just simplify it,
Okay. So
and
like,
then that would be boom. You did
now,
it.
yeah. Now keep in mind, it says find the value of x. So we are done. But if it said to find the lengths of the missing sides,
Oh, then we'd have to use the It's
you'd
I
have to,
can't remember the formula for it, but I
no,
know it's like a square root.
no, you don't need Pythagorean theorem. You just need to put the number back in
Uh-huh.
because you have
Oh,
x. That's
oh, right.
what I'm trying to say is that You may have to do a little bit more, like make sure this is kind of an SAT thing, like make sure you're actually solving for the thing they're asking for.
So then, yeah, so then I'd have 7.5, 12.5,
Right.
and
And
10.
so now to answer your question, and let's do that real quick here. Okay. 10, 7.5, and 12.5. Does the Pythagorean theorem hold? Like
No.
square. Well, it's a right triangle. It should. It should. Is 7.5 squared plus 10 squared equal to 12.5 squared?
I do not know. I'd need to
You can
calculate.
you can use a calculator, yeah. But I want you to do this because this is a
All
verify
right.
step. Plus, you might see something like this on your your tester quiz.
Equals 12.5 squared. All right, I'll start typing that in. Oops. Plus. So then 7.5 squared plus 10 squared is 156.25.
Okay.
And then 12.5 times 12.5 is 156.25 as well.
So they are the same.
And then that means that I'll be honest, so that's showing the like lengths to all the sides.
Yes.
So it's just showing that they
That it,
equal the same,
yes. Yes. It's
therefore making the answer correct.
yes. Yes. Okay. So let's use those numbers here, and I'm just going to redraw it here because we haven't done this. We haven't done this yet. So 10, 7.5. Now let's say you didn't know the third side. Okay. That's when you would use the Pythagorean theorem.
And that's a squared plus b squared equals c squared.
Yes. Okay. So let's say you did that and you found that the third side was 12.5. Okay. Let's say we wanted to find angle A. Angle A. So are we going to use sine, cosine, or tangent?
I'm thinking because I'm using the adjacent and the opposite, right? I think tan.
So the answer is actually we're going to use all three. You can actually use any of the three here. So we're going to use all three. Okay. So let's start with sine. Sine of A equals relative to A. Tell me what's opposite and what's hypotenuse.
7.5 and 12.5.
Okay. Now how do you undo the sine?
Uh, multiply it by 12.5.
How do you undo sine? Nope. We did this. I think we did this the other day. Remember sine inverse?
Oh, right.
Okay. So
And
A
so I use
equals,
that when there's no angle that's
that's right.
like given that. So then sin, I mean sine, I did it. Sine minus 1, 7.5, 12.5, sine minus 1, 7.5, 12.5. So then okay, so then
So
would I
go to
just
your
under
calculator and do the sine inverse. You're gonna have to go under for function. You're gonna have to grab the sine inverse and then fraction bar 7.5 over 12.5.
7.5, and you said divided by 12.5?
Yes, exactly what you see on the screen there. And tell me what you've got for an answer.
36.9.
Very good. Now, I mentioned that we could use any of the three. So now we're going to do it with cosine. Cosine of A is what divided by what in this problem?
The adjacent and hypotenuse. So 10 over 12.5.
Okay. And then how do you undo cosine? How do you get to the angle?
You're gonna have cosine minus 1 times cosine.
Okay.
And then
So make sure now, yeah, they undo each other. You don't have to show it every time, but you can.
okay. So then I'd write cosine minus 1, 10, 12.5. So that, let's see, clear all. 11 times, no, 10 divided by 12.5.
Yes.
So cosine minus 1, cosine minus 1, 10 divided by 12.5, 10 divided by 12.5. Whoops, I clicked the wrong. 12.5. 36.9 as well.
Okay. So notice it's the same answer as before.
And that's because I can use all three of them because it
That's
all
right.
goes.
So let's do the last one just to close this out here. This part of the finding angles. So this time it's 7.5 over 10. So A is tan inverse 7.5 over 10.
7.5 over 10. So then 7.5 over 10. And I'm just going to write this down. 7.5, 10, 10. All right, so now clear function tan minus 1 back to main 7.5 divided by 10, which, big surprise, 36.9.
Yep.
And then I guess that, so that's just, so then that would be the angle of A is 36.9.
Yeah. And how would we find angle B now if we have the other angle?
We know the other, so we know that's 36.9. We know there's 90. So then 90 plus 36.9, 90 plus 36.996, 12. So it's 126.9, 180 minus 126.9, what? 63.1.
Yes. Very good.
All right, I got it.
Okay, we got 5 minutes left. So look through your paper real quick, see if there's something else we can go through. That would be worth spending a few minutes here. If not, I'll pick a problem that I think is worth looking at.
All right, I'm checking right now. Maybe. Because like tan sounds good. I guess maybe most of it's just all kind of like stuff we went over. Maybe the 20-foot. I guess we kind of already did that though. The 20-foot ladder kind of problem is just like that's kind of just a combination of all of this.
Yes.
Maybe the problem. Do you see the problems where they have like the data tables?
Yes. So we
Maybe
don't have,
one of those.
yeah, we don't have enough time to go through all of that. We have enough time, I guess, to start something on that and
Uh-huh.
go through it. But yeah, that's a good one to do. So let's and I'll just do 7 because 7 is probably the easier one. 7 is a 45, 45, 90 special triangle.
Hmm.
Do you remember why it's called 45, 45, 90?
It's 90 degrees and 45 and 45.
Right. So the two legs are the same. All right. They're called, let's call them X and X. Okay.
Oh,
So to go from the leg, if you're given the leg to go to the hypotenuse, you multiply by the square root of 2. Okay. So your hypotenuse is X square root of 2.
hmm
Okay. So let me give you a quick example here. Let's say the leg is 8. What's the other leg?
That would also be 8.
And the hypotenuse is 8 square root 2.
8 square root 2.
Because you take the leg and you multiply by the square root of 2. Now let's do another one here. Let's say I give you the leg. The leg is 11. What's the other leg?
11 square root 2.
Yes. Okay.
And then would I be using like a squared plus b squared equals c squared in
It
this?
does work. Like if you took 11 squared plus 11 squared, does that equal 11 square root 2 squared? You will find that it in fact does.
Yeah. Okay. And
Now
then
they get harder. Like I don't want you to think like, oh, I've got it now.
oh,
Do you have a follow-up question to that?
so once I get that answer, like what is that necessarily showing?
Well, so your table, I can't really, let's just say, I think the table's like this: leg,
Oh,
leg,
right. So I got it.
hypotenuse.
That.
So for our first one, it was like 8 square root 2. What did I do here? 11, 11 square root 2. But it gets harder. I'll give you another problem here. Let's say the leg is 4 square root 3. What is the other leg?
4 square root 3, and then
You have to
4 square
multiply,
root 3 times square root 2.
and that's 4 square root of 6. So in terms
Okay,
of so in
I
terms
see
of
how that
so in terms of your table, again, it'd be 4 square root 3, 4 square root 3, 4 square root 6.
is. Okay. All
Yeah.
right. I think I understand how that table thing kind of works.
They're just they're making more problems than, it's more than one problem. They're making like 1, 2, 3, 5 problems out of one. So let's say, how about if it's 12 square root 2? What is the other leg?
12 square root 2, and then that'd be 12 square root 2 times 2, which is then 12 square root 4.
And what does that become?
Uh, 3 and 1? 3 square root 1?
Square root of 4 is 2, so it's 12 times 2.
Oh, right. Yeah. I did not think that through. Yeah, 12 square, yeah, and then that'd just be 24, and then you'd write 12 square root 2, 12 square root 2, 24.
Yes. Now there's the other direction here. There's what if I give you the hypotenuse, okay? That's why I said we only have time to go through one of these. So let's say I tell you that this is 15 square root of 2. I'll draw the reference triangle again.
I guess I'd know x and x would have to be 15.
That's right. Okay, and that's pretty easy. You're like, oh, I got it. Well,
Uh,
what if I don't give you a whole number? What if I make it 6? Or I don't give you a
um,
square root? So you're now
and I
dividing.
know so in order for it to be 6, it has to be divided by 2. So then would it be 12?
So the way to do it is you divide by the square root of 2 to get x.
Okay, 6 divided by square root 2. So then that would be like,
And you have to rationalize the top and the bottom.
mm,
So this is over 2, and it becomes 3 root 2.
3 root 2. So then, so x would have been 3
Root 2.
root 2. Huh. Okay.
So unfortunately, like this is, we could actually do a whole lesson on 45, 45, 90, and 30, 60, 90 triangles.
Uh,
You do have your lesson. I mean, do you have tomorrow as your, your regular lesson time? I mean, what's your feel on that? Do you think that you're going to need, I mean, not, do you know if your test is tomorrow, or is it just